Hi, this is Jeff Evans from Evans Performance Academy. We're going to be taking a look at some basics with our PC Link software so you can get started with your Link G5 or G4X system. Without further wait, let's jump in to check this out. Okay, so let's get started. We're going to be taking a look at setting up an analog type of wideband input for our Link G5 and G4X programming. Now, when we're talking about a Lambda sensor, this allows you to measure the fuel to air ratio in your exhaust stream. Specifically, it's measuring the oxygen content. So as we have a richer amount of fueling delivery to our engine, it's going to have less oxygen content and report that to us as an air fuel or a Lambda reading. Again, if we have less fueling, we'll have higher oxygen content and it would report that as a leaner air fuel or Lambda reading. We have to have a Lambda reading to do any calibrating and tuning for our fuel within the link. So you will be dealing with some type of a Lambda input to your G5 or G4X box. Now, when we're talking about the G5 Voodoo Pro specifically, that's the first box here released from Link, and that's what I'm working with here, that has two onboard or built-in Lambda circuits, meaning we don't have to have an external wideband gauge or controller that we have to integrate. It has everything housed into the end connector on the Voodoo Pro, so we can actually run two Bosch LSU 4.9 wideband sensors directly from the link. And this is probably the best, most reliable option that we have for working with the G5 system using that built-in Lambda circuit. However, if you have a G4X or for whatever reason you don't want to use the internal wideband circuits, we can bring in the Lambda reading from an external controller in two other options or methods. One would be a CAN-based type of input. That's going to be if you have an external link or another type of CAN-based wideband control like an AEM X-series, we can broadcast the reading of the Bosch sensor coming from the actual wideband controller. We can broadcast whatever that's registering and reading and broadcast that through CAN bus into our link device. So again, whether that's a G5 or a G4X, we can work with a CAN-based Lambda. We also have the ability, in which we're going to cover in this training module, at working with an analog type of input. So this would be if you have an external wideband gauge, such as an AEM Uego or an Innovate gauge, they're going to be able to take the Bosch LSU reading from the sensor. It's going to bring it into the gauge. The gauge is going to process that, show it on the gauge display, and then the gauge itself will then output a 0 to 5 volt scale, and that is something that we can translate in our link here to an air-fuel Lambda reading. And that's what we're going to learn how to do in this training module. Now, this is definitely the least desirable option of the three. If you have a G5 box and it has those built-in wideband circuits, that's the first choice. The next best choice would be a CAN Lambda. Then this would be the third option, the least best choice of all of the options, and bring in analog signal. I'm going to cover it here anyway, because if you're dealing with a G4X controller, it still runs the G5 software. In a G4X, you do not have a built-in Lambda circuit. What you'll have is going to be the CAN option or the analog option. And there is one exception to this. The G4X Fury, so it's a universal box, the Fury box, has one single built-in Lambda circuit. That is the exception across the entire lineup of G4X devices. But if you're dealing with a plug-and-play G4X, for example, they do not have that built-in Lambda circuit. So in that case, you will need to run some type of an external Lambda wideband controller, whether it's CAN-based or it's analog-based, as we're going to discuss. So let's dig into our tutorial here and learn how to set up an analog type of Lambda sensor from a external controller. So we're going to move from our basics page right here, and we're going to go over here into our analog input window. Now, if we move down here, we have a couple options on the very lower left-hand side. We're going to find we have Lambda 1 and Lambda 2. We have the ability to bring in two different Lambda readings to our G5 or G4X that we're working with. In this case, I'm going to only be setting up a Lambda input 1 or one Lambda sensor. I have an inline 4-cylinder engine, so I have a Honda K20 engine, and I want to go ahead and set this up so I'm able to monitor and measure our Lambda from our sensor. And we're going to be working with, in this first example, an AEM Uego gauge. This is a very basic, kind of old school wideband gauge. It's been on the market for probably at least 10, 15 years now. pretty reliable. They work fairly well. And this allows me to broadcast the reading from an AEM UAGO gauge into the link and being able to translate a 0 to 5 volt scale from that gauge output to a Lambda reading. Now, one thing I want to mention is that there is something called a voltage offset. So once we've programmed and set up everything here for the analog type of input, there's a possibility if you compare what your gauge reading is showing to what the actual link is showing, there might be a discrepancy there. That is what's known as a voltage offset. So meaning the actual gauge is broadcasting a certain amount of voltage out, but there's a slight difference or deviation when we broadcast that voltage into the actual link. And the voltage offset is something that a lot of times we can't really offset, we can't fix. So just be aware that sometimes there's going to be a slight discrepancy in your actual gauge reading, which is the accurate reading, to what you find coming into your link. All right, now how do we do this? This is pretty straightforward. If we jump here under our Lambda 1, we have our Lambda sensor control. This is going to give us the ability to select various different options here for working with a Lambda sensor. Right now it's set to none, meaning this channel is shut off. We want to turn it on and we actually want this to function. We can find we have an option here, internal. That would be if you're using one of the internal widebands for your G5. In this case, we're not. There's a link CAN option. This is what we would choose if we're running a link external CAN Lambda module or any other wideband that's CAN based. So an AEM X-series is something that I frequently use with link products that works extremely well, the inline wideband specifically. And you would choose link CAN no matter what, even if you're not dealing with an actual link CAN Lambda wideband. So we're going to be covering that in the next training module. We have the other options here of selecting an analog voltage input. There is also some CAN analog volts. We're not going to get into setting that up because it's not really useful for this. We're going to work with our analog voltage 3. That's where I've wired the white wire, which is the 0 to 5 volt wire for my AEM UAGO wideband, into my G5 here. So this is the first step, is it assigning the actual source of where we have wired the signal from the analog wideband. So let's go ahead and choose analog volt 3 and click OK. Now we have an error low and an error high. We also have an error value and then the calibration. Finally, down here below, there's a run when stalled. Now, when we're dealing with an external wideband option, specifically in this analog type of situation, we want to make sure the run when stalled is set to no. We don't want this to run, and it's not going to matter anyway. This is for the internal control of the internal widebands. We can actually keep the wideband hot and keep it on when the engine is stalled out. So you may want to shut that off in the internal option so you don't have as much amp draw on your battery. So it might be something you want to consider. For right now, it doesn't apply to us. We want to make sure this is set to no for this external option. Okay, so the next thing we need to take a look at here is setting up our calibration scale. Then after that, we can take a look at the error low, the high, and then the error value so we can populate all this information. So looking here under the calibration, we double click, we have the ability to go in and choose some preset options. So we find AEM X-series UAGO, we have an Innovate LC1, we have an NGK, we have Ultronic widebands, Zetronic, and going down here, we can also choose a calibration table or a linear calibration table. We're actually going to be using the linear calibration table in this situation because we're dealing with an AEM UAGO wideband, which is different than the X-series wideband. So we need to jump into the datasheet or the PDF from the instructions for the wideband controller that we're working with to determine the proper scale so we can set the proper voltage to lambda conversion. So when the link is reading the voltage being broadcasted in from the wideband, it can translate that to a proper air-fuel lambda reading. Okay, let's take a look at this real quick. So I have this open on my web browser. If we scroll down here, I'm on the AEM, in this case, 304100 part number. So that's the gauge type UAGO controller. If we scroll down here through the instruction sheet, we're going to find we have some wiring that we should pay attention to. So this will just give you kind of an idea of what's going on here in terms of how the gauge works. We have our wideband, fit it into our exhaust. We have the connector plug, which is plugged into the gauge. We can see that right here. Then coming out of the gauge, we have a harness that's going to be our 12-volt power, our chassis ground to actually power on the wideband controller itself. Then we have a white wire, which is our 0 to 5 volt output that broadcasts what we're bringing into the link. Then there's also a blue wire, which is a serial output. That's not going to apply to this. We don't need to worry about that. So this white wire is what we're wiring into the link. Just wanted to make sure that we're aware of that. The next thing we need to take a look at here, if we scroll down, is the conversion scale. We can see here on the left, there's the volts. So this is going to be what comes out of the gauge, 0 to 5 volt scale, and what that correlates to or corresponds to in the gasoline air fuel scale. Now we can see here 0 correlates to 10 to 1 air fuel, and 4.99 correlates to 19.98 air fuel. Now, what we can do here is actually set up the link so that it's going to work in gasoline air fuel units just to program this, but we probably want to go and set it back onto then units of Lambda for actually tuning. This makes things much more simplistic. We're gonna have another video talking about the difference between air fuel, Lambda, and stoichiometric, so that tying these all together will make more sense, but you can just think of the air fuel that we want to take from our scaling right here and the Lambda reading in the actual software here. So if we go back in, this is all going to be in units of Lambda when we actually program it here in our scale. That's the difference between something like Fahrenheit and Celsius. So it's really a unit scaling difference. So this will make more sense again when we go through that Lambda, Stoich, and air fuel video. But for right now, we need to program the scale. So let's just get this out of the way. So what I'm going to do right now is jump down here into linear Cal 3. We know if we take a look back here real quick at that PDF, 0 volt, 10 to 1, 4.99 volt is essentially 20 to 1. It's a linear scale between. So that means that as we have an increase in voltage, it'll have an increase in proportional difference in air fuel reading. So we can just use 2 points of data to be able to set up our wideband. So let's go take a look at this real quick. Jump back in here, we're gonna use linear Cal 3. So you could use any of these linear Cals. I'm just gonna use the third one, that one's open. We'll click OK. And now we can find here the label. We'll call this AEM UAGO. So we have that as our wideband name. The input value, that's gonna be the lowest minimum voltage, that is 0 volt. The input value B, it's the highest input voltage from the controller, which would be 5 volt. We have to go in and work in output units. In this case, it's going to be in units of Lambda. Now we're going to fix this so we can correlate what's on that data sheet into the proper unit scale here, but we have to choose units of Lambda for right now. Let's click OK. Now the next thing here, we have our output value A, output value B. This is saying at the minimum volt, what's the associated Lambda reading? And at the maximum volt, what's the associated Lambda reading? Again, we're in units of Lambda. We can take a look here in our data sheet. It's actually not giving us what those correlations going to be between voltage and Lambda. It's going to be between voltage and gasoline or petrol air fuel scale. What we need to do right now is set the software so it's going to reference units of AFR or the gasoline petrol air fuel. Then we can go in and translate what we have here in the data sheet to the link programming. Let's go in here real quick and do that. So we're going to move up here into options. We're going to go in here to units. We're going to go in here to options. And I have it currently selected on the metric units. We're going to go and convert our Lambda reading to air fuel. Click OK. Give that a second. That's going to update things here. And we should find, when we go ahead and select that, that the units here should go and correlate to air fuel. It looks like it's taking a second here for that to take. We'll just be patient until it converts that real quick. So we can see here now that the units have been updated to units of petrol air fuel, which allows us now to go in and set up our A and B outputs here. So it's going to match the scale here, the min and max voltage. So going back to our data sheet real quick, we're going to find 0 volt is 10 to 1 air fuel. So we're going to go populate that right here. Nope, not this. Let's go here to our A value. So 0 volt, 10 to 1, 5 volt, should be then 20 to 1, and we'll just double check that on the data sheet here quick. Jump in. We can see here 4.99 volts is 19.98. So that's going to be close enough. I just rounded up slightly. So that will be our calibration scale right here. Let's go ahead and store that to the ECU. And now we can take a look real quick under our Lambda 1 reading. This is showing units of air fuel. We're seeing it showing 18.93. So the engine isn't running right now. I'm key on engine off, and I find that there's no combustion happening. So the oxygen sensor is measuring the oxygen content in the exhaust stream. Because there's no combustion, we'll find that there's a huge amount of oxygen, and that's why it's reading this full lean value. So the higher the value, the leaner; the lower the value, the richer, looking at this channel. But we know now it is actually registering and reading, and we have a checksum on that. One thing I want to make you aware of is when you're taking a look at your Lambda reading, you have a situation with an analog input to your link where the external controller, the gauge, in this case, the AEM Uego gauge, when you turn the ignition key on, it will take about a 20-30 second window before the wideband starts to register and read anything on the display. What will happen in that same period of time is that it's going to be broadcasting out to the link a default or a generic value. So the air fuel here for the first 20-30 seconds on startup, whether it's cold start or hot start, it resets the wideband, the heater circuit starts to work and starts to heat up the sensor so that it's accurate before it displays on the gauge. As a result, you'll find that your reading here is going to read either full rich or full lean. It'll be an inaccurate reading. So that's fine. Just be aware that that is another kind of quirk with this, that the output from the gauge will be showing some kind of an odd value for the first 20-30 seconds. Then it will start to broadcast and read properly. So pretty simple there. Now, the other thing we need to take a look at here is the error detection. When it falls below or above the voltage range, we have something wrong with the actual output. So maybe something's wrong with the gauge, maybe something's wrong with the wiring from the gauge to the link. Maybe there's something happened there, a wire got broken. We want it to go in, because we're using the air fuel reading usually for closed loop and for Lambda lean protection. We want to make sure that if there's a problem, it will have some reading or error value that it's associated to an open circuit, so a low or high voltage, and it's going to go ahead and default to that. And it'll also flag us and tell us that there's a problem here in the link. So what we need to do is take a look at that total scale, the operating scale of the actual input we're working with from the gauge. In this case, we would have to set the low and the high below and above the range of output from that wideband gauge. Now, we're in a situation here with the AEM Uego where it's a full 0 to 5 volt scale. In this situation, we can't have error detection because we can only put the low value as low as 0 and the high value as high as 5 volt. So in this case, we're not able to have that error detection with an AEM Uego. However, if you're dealing with something like an Innovate gauge, or you're dealing with something like an AEM X-series gauge, you do have the ability to do this because the scale isn't a full 0 to 5 volt, at least on the AEM X-series gauge. The error value is going to be what it defaults to if it falls below or above this voltage thresholds. I'm going to go ahead and just set this to 14.7 or 1.0 lambda. That's going to be what it defaults to if it faults out. In this case, we don't have that fault detection, but if we did, that's what I'm going to allow it to go to. Let's go ahead and store these changes to the ECU. So we do see key on, engine off. The wideband is reading full lean. That's normal. Everything is calibrated properly here in our linear calibration scale. The last step here for me would be putting the unit scale back to units of lambda. So if we go in here to options and we go set this back here onto units of lambda. Now it looks like, if I flip over here, it looks like I have it set to units of imperial or standard units. Let's flip it back to metric and we can see that's now going to automatically translate that voltage air fuel relationship to a voltage to lambda relationship. Again, it's just a unit difference, same as Fahrenheit to Celsius. It'll go ahead and convert that for you, so you don't need to worry about doing the conversion. We can just use the data from the data sheet and copy it as we have it presented. All right, so this was an example for setting up an AEM Uego gauge. What happens if we have an AEM X-series gauge and we want to wire it in an analog configuration and not using the CAN bus option? We'll talk about that in the next training module, setting up an AEM X-series with a CAN input to the link. But what if we want to wire this in for an analog input? Let's jump up here. I have the PDF sheet open for an AEM X-series gauge. So this is the data sheet here. And if we go down just a little bit, let's talk about this real quick. This is something important to note. When we're taking a look here, this is the gauge. The sensor would be coming into the gauge. This is what it's broadcasting out or it has coming in. So for example, there's a power and a ground coming in to actually power the gauge on so it works. but we have a lot of outputs coming out of the gauge. We have a blue serial output, not used, don't need to worry about it. We have a white wire, that's our analog plus, that's what we wire in for the link. We also have a brown wire, an analog negative. This was not present on the AEM Uego gauge. The reason why I'm mentioning this, and this is super important, this analog negative brown wire, if you're using any of the X-series wideband gauges, must be connected to a sensor ground at the link. If you don't connect the brown wire, there will be a massive voltage offset. And what you see displayed here on the gauge will not match what's coming into the software. Super important that that analog wire is connected, the analog brown wire, negative wire. A lot of people don't connect this, they just connect the white wire, which leads to a lot of problems. So just be aware of that. Okay. So the other thing, we actually can see that illustrated right here. So brown analog sensor ground, this would be if you're using an Infinity. Doesn't matter which standalone you're using, that brown wire, whether it's a link or an Infinity. The brown wire, analog negative, has to go to sensor ground. White analog 0 to 5 volt, that's what we would broadcast into the actual link, just as we did with the AEM Uego. So for this situation, if we scroll down a little bit more, we're going to find the calibration scale given for this actual controller here. So if we go down just a little bit, keep going a little bit more, it should find it right here. So in this case, they're actually giving us the Lambda and the petrol air fuel scale. We see the voltage here on the side. Now the AEM X-series wideband gauges, whether it's the inline or the gauge itself, they all run the same calibration scale, which is nice. So we can note that 0.5 volt is the first minimum volt, and then 4.5 volt is the maximum voltage output from the white wire 0 to 5 volt into the link. And then we find the associated Lambda or air fuel reading. So this is an 8.5 at 0.5 volt. 4.5 volt would be 18 to 1. So it has the scale right here. Simple, we set it up just in the same manner as we would if we were setting up an AEM Uego. However, there is something important here to note. Let's jump back into the software. We actually have an AEM the AEM X-series wideband found right here into the options as the very first choice right here. So you would go ahead and just select it right here. So that makes it super easy to set up an AEM X-series wideband. And again, with this option, make sure that brown wire is connected, or what you find displayed on your wideband gauge will never match what the link is showing, because there'll be a 1 to 2 volt offset between the gauge reading and the actual link, which makes things completely inaccurate, and it's not useful for doing any tuning or data mounting purposes. All right, so the other option here, just as I was going to go through just kind of another example of another wideband, an Innovate wideband. These are pretty popular. We'll find in this case, same deal with the Innovate. We're going to find, we want to check our wiring here. So we see that there's going to be a whole bunch of different wires coming out, and they're going to explain what these wires actually represent. So there's going to be a red wire, that's our 12 volt, a black wire, that's our ground. The white wire, this is going to say going here to the headlight power. That's going to be for dimming the wideband gauge display itself. There's a yellow wire, analog 1 out, or a brown wire, analog 2 out. So there's actually 2 different outputs here that you can use with the Innovate gauge. Now we're going to be using the yellow analog 1 because it's going to send a 0 to 5 volt scale, and they actually call out that scale right here in their instructions. 0 volt is 7.35 air fuel, 5 volt is 22.39 air fuel. So in this situation, we want to use the yellow wire that we're wiring into the link. Now, looking through the rest of the PDF or instruction sheet, I don't see an analog negative wire that has to be tied to a sensor ground for this to actually work. So they're not calling that out in here. So it looks like what we find on the AEM Uego gauge, which is a white wire 0 to 5 volt that we run into the link, the yellow wire will be the same equivalent, and we would have to go and update the linear calibration table 3 to represent this scaling that we find right here. So jumping back in, we'd have to call that out in this parameter box right here for the linear cal 3 and point that to running that specific linear calibration table for it to translate the voltage to a Lambda air fuel reading. So pretty simple, pretty straightforward here of how to set this up and how to work with this. There was no real tricks going on with this, nothing really tricky to set up, but you just do have to be aware of on the AEM X-series, again, that brown wire. I see it's a very, very common mistake that people make, they're not hooking up the analog negative, and then it causes all kinds of problems because, again, what you find on the display, which is the correct air fuel reading, does not match what's broadcasted here into the link because of a voltage offset. Thanks for watching our tutorial. If you're interested in learning more about how to tune your Link G5 or G4X system, check out the video description below where you can find links to our school, some promo codes to get you started and save some money. If you're interested in learning more about Link engine management products, also check out the video description below. That's going to wrap it up here. I hope to see you guys in our school.